dear student. In the previous class we have studied about combination of capacitor. In that series combination we already discussed. So let's continue the next part, that is the combination of combination of capacitor in parallel. Parallel combination of capacitor. The capacitor are said to be connected in parallel when they are connected between two common points such that, here the capacitor are said to be parallel connection when they are connected between two common points such that in parallel combination the potential difference across the two capacitors are equal to the applied potential, and here the charge applied to this, the total charge in this capacitor, in the combination of capacitor, is the sum of the individual charge of a capacitor. Therefore Q equals to Q1 plus Q2, but here potential difference is same. This is regarding about the definition of parallel combination of a capacitor. So let us understand by a circuit diagram. We consider a two capacitor, parallel plate capacitor, are connected parallelly, and these two common points are connected to a battery to supply the potential difference by a voltage. This is positive, negative. Here also positive. This is A, B, this is Q1, this is Q2, C1, C2, and this is positive, this is negative, this is voltage. So here the potential difference across these two capacitors is same as the applied potential, but the charge of these two capacitors is the total charge of this whole circuit is equal to the sum of these two charges, that is Q1 and Q2. Then we have to derive this formula. Here A and B are called as two capacitor, and Q1 Q2 are the charges of A and B respectively, and V1 and V2 are the, here B is common, C1 and C2 are the capacitance of a capacitor A and B respectively. A capacitor A and B respectively. Therefore here potential difference is same. Therefore here the total, we need to find out the total charge in a capacitor. The total charge of these two capacitors can be defined as Q equals to CV. Here B is constant. Therefore Q1 equals to C1 times Vb, and Q2 equals to the charge in a capacitor C2 equals to C2 into V. So here the total charge is equal to Q1 plus Q2. This is called as equation number 1. So apply these two values, this equation 1 becomes Q equals to C1V plus C2V. So here the combination of a capacitor can be replaced by a effective capacitance of this capacitor. Therefore Q equals to C P into V. here V is the common point, take it outside, common term C1 plus C2. So in the both the side V is same, therefore V get cancelled. The final equation becomes C3 equals to C1 plus C2. This is the final required equation when the capacitor are connected in parallel. It is only for two capacitor. For example, we consider three capacitor. The final equation become for three capacitor. Three capacitor are connected in parallel. Therefore, Cp equals to C1 plus C2 plus C3. This is about the three capacitor are connected in parallel. So here the total capacitance of a capacitor is the sum of the capacitance of a individual capacitor. This is regarding about the parallel combination of a capacitor. Then what are the uses of capacitor? So capacitor, it is used as a energy store. It is used as to store electrical energy, electrical charge or energy, electrical charge, and it is used as a used in TV, radio, etc. Used in TV and radio, and it is used as a potential divider. Potential divider, and it is used in the AC circuit to generate a electrical charge, and also it is used to generate a electrical energy in a small gap. This is about the uses of a capacitor. Next concept is quantigraph generator. Quantigraph generator. Quantigraph generator means generator. We know that the generator means it is a device used to convert mechanical to electrical energy. But quantigraph generator, it is a device used to produce high voltage energy. It is a device used to produce high voltage about 10 to the power of 7 volt. This is called as quantigraph generator. Then what are all the principle and the basis of work a quantigraph generator? Therefore, it depends on, it works on the principle. It is work on the basis of discharging point, discharging action capital R. This is potential of capital R. This is V of small r. Here the charge, here the charge is Q, here the charge is small q. This is V of small q, small q of R, small r. This is the capital Q of small r. So here R is the radius of a shell, of a charge Q, and small r is the radius of a sphere of charge small q. So here R is the radius of a shell with a charge q, and small r is the radius of a conducting sphere. Conducting sphere of radius small r. This is radius of charge small q. Therefore, here the potential due to Q on the inside and surface of a shell is given by I will conclude here, that is V of R equals to 1 over 4 pi epsilon naught Q divided by capital R. So this is the potential due to a charge Q on the surface or inside the shell. This is the shell, conducting shell. This is the conductor of sphere, conducting sphere of charge Q. This is charge Q, capital Q. And the next one is the potential due to small q, potential difference due to Q, small q, on the surface of a sphere is given by V of R equals to 1 over 4 pi epsilon naught Q divided by small r. So therefore the total potential due to capital Q and small q on the surface of a shell is given by therefore V of R equals to V of capital R plus V of capital conducting shell. And the next one is the total potential due to a charge q and small q on the surface of a sphere. A conducting sphere is given by is V sphere equals to V of q plus V of small q. Therefore, 1 over 4 pi epsilon naught q divided by r plus 1 over 4 pi epsilon naught small q divided by small r. So this is regarding about the total potential difference. This is one, question number 2. So therefore the total potential on the sphere and the shell is given by therefore the final equation is the total potential on the shell and the sphere is given by V total equals to V sphere minus V shell. Therefore 1 over V sphere means 1 over 4 pi epsilon naught capital Q divided by R plus 1 over 4 pi epsilon naught small q divided by small r minus of this 1 over 4 pi epsilon naught capital Q divided by r minus plus 1 over 4 pi epsilon naught small q divided by capital R. So here the first term and third term get cancelled. Remaining thing is 1 over 4 pi epsilon naught q divided by r minus 1 over 4 pi epsilon naught q divided by capital R. Therefore, take it outside. The common term is q divided by 4 pi epsilon naught. The remaining thing is 1 by r minus 1 by capital R. This is above. And this is regarding here. R is the radius of a sphere, capital R is the radius of a shell. Here V sphere is greater than V shell. Therefore, here the charge is flow when a conducting sphere is placed inside the shell. The charge is moved from the sphere to the shell. Because here we know that always charge flow from high potential to low potential. This is about the principle of Van de Graaff generator. Next thing is the construction and working of Van de Graaff generator. This is the schematic diagram of Van de Graaff generator. So first we are going to discuss the construction of this Van de Graaff generator. Construction here. So consider a very large radius of a shell and it is supported by a long insulating column from the ground level. And here consider a belt, insulating belt made up of a silk or plastic. It is wounded down to the two pulleys, and P1 and P2 are the two pulleys, and here B1 and B2 are the This is P1. This is P2. B1 is connected to the pulley P1 and B2 means the metal brush collecting a charge is connected to the upper end of the pulleys, that is P2, and then here the end point is connected to the pulley belt, and the other side of this brushes is connected to the inner side of a shell. Then the working of this Van de Graaff generator. Once again I will repeat the construction here. A large sphere of radius is stand by a insulating column of some height from the ground metal base, and it contains a two pulleys P1 and P2. P1 is connected to the lower end and P1 is placed in the center of a metal sphere and it is connected by a belt. The belt is made up of a insulating material like plastic or rubber, and it is wound around to the two pulleys, and B1, B2 are the two metal brush collecting a charge, and it is delivering a charge from B1, and B2 is a collecting charge. The ends of the brushes is connected to the end of a pulley, and other side of the brush is connected to the inner side of a shell. And move on to the construction part. Here, next thing is working part. Here we apply the positive potential to the belt by a B1, and the belt is transferred and collecting and transfer the positive charge and transfer the charge to P2 by a B2, and the positive charges are positive potential are spread out a sphere uniformly. This is about then only we collect a 6 to 8 volt of potential. In this way we can generate a very high potential by a Van de Graaff generator. This is regarding about the construction and working part of a Van de Graaff generator. This complete your